My name is Jamie Brunkow. I'm the Sassafras River Keeper. I work for the Sassafras River Association. And I'm going to attempt to pack in a lot of information in about a 15-minute slot here, giving you some background on the Sassafras River Association, what we do, some special characteristics of the Sassafras River. I'm sure it's a place a lot of people in the room aren't familiar with. It's a really small river on the eastern shore. We're going to talk about SRA's monitoring program, and we're finally going to get to the report card, which was released in the past fall. So a little bit about who we are. We are a 501c3 not-for-profit. We started back in 2004, so we're a relatively young organization. We've only had staff since 2008. Our first monitoring program didn't get started until 2009. So we're really kind of new to this in a lot of ways, but we've hit the ground running. I'm going to talk about that more a little bit later. We are a membership organization. We have about 550 members representing a lot of different backgrounds. Farmers, well, we have a lot of marinas in the Georgetown area. There's a concentration of Marina 7 on the entire river. And of course, we have local businesses. We interact with our county commissioners and local leaders as well. We have 5 staff as of now, an executive director, a river keeper, a watershed coordinator who also does some of our water quality sampling work and analysis, and an admin assistant, as well as an ag outreach coordinator. So we have 3 primary core programs. This is when we go out and we talk to the public, we say that we focus our work in these 3 primary areas: advocacy, restoration, and outreach. And you may be wondering, where does water quality monitoring fit into there? And I think this is a good time to point out how prevalent our monitoring program is through all of these programs. Advocacy, our monitoring work gives us the scientific data, the background to be the scientific experts in our watershed, to have the most knowledge about our watershed, about the local issues. So when it comes to advocating for preserving a piece of land because of sensitive species or because of water quality impairments, we have that data to back us up. It gives us that expertise. Restoration, that's a huge program for us. We are a small watershed, so we don't just focus in one area. We have to kind of be the experts in every area. We don't have a separate nonprofit on the other end of the Sassafras River that does just education or does just restoration. We have a few really exciting projects coming up in the next year. One in particular is going to be a wetland restoration. And we used actually some of our original water quality data to select that site. We had really high nitrate and phosphate content or concentrations downstream of a farm where there's a CAFO, a confined animal feeding operation, just upstream of that site. Outreach. We involve at least 30 volunteers a month in our Nontitle sampling program. Outreach is a huge component of this. Even if we don't find some amazing new fact each time we go out and sample, we're involving the community. We're producing the report card, a publication as a result of the data, and it's a great way to reach out to people to educate them about what we're doing, what the water quality problems are in the river, and how they can get involved. So for those of you, again, who aren't familiar with the Sassafras Watershed, we're on the upper eastern shore of Maryland, just above the Chester River and below the Elk River Basin. It's a mostly tidal fresh throughout the year. We do get some oligohaline salinities towards the end of the summer, but we see very low salinities throughout the year. We don't have oysters, we don't have jellyfish. We do have some other problems. Watershed characteristics. The vast majority of the land is agricultural land use. So I'm telling you this so you can start kind of thinking about it in your own minds. What are the main sources of pollution in our watershed? When we're looking at our actual water quality data in a few minutes, keep this in mind. Think about where it's all coming from. We have, like I said, a majority of agricultural land, but we do have a good amount of forest too. We actually have a state preserve in Kent County, and we have some land in Cecil County as well that's owned by DNR that's in preservation. But just because we have this forested land doesn't mean we don't have problems associated with that. Just like a parking lot can act like a conduit for stormwater, a farm field can do the same thing. So when we have really heavy rains or sustained rains, it's not uncommon to see large sheet flows coming off of farm fields and going into these wooded areas. And woodland gullies are a really prevalent issue in our watershed. And those are some of the restoration projects that we have upcoming. We've applied for several grants, some that are pending at the moment, but restoring those woodland gullies is a huge priority for us because they just keep getting cut deeper and deeper into the landscape, supplying more and more sediment and phosphorus. We also have a few towns within our watershed, Galena and Betterton, just a little piece of Cecilton. By no means are we an industrialized watershed, but we do have some stormwater to worry about, and we are working with each of those towns to try to have the greening projects where we plant trees. We have low-impact development in parking lots and things like that, and we're looking to install some rain gardens in the next year as well. As I mentioned already, we have several marinas within our watershed, huge boater population in the summertime, a lot of people come to visit, have part-time residencies in the Sassafras Watershed. Below here is a threatened species that calls the Sassafras Watershed home. One really unique quality of the sassafras are the cliffs that you see as you get further out towards the bay. Very beautiful scenery. You see bald eagles soaring around there. So I see bald eagles on my drive to work a lot of days. So getting into the monitoring program. We have two primary programs. We have our tidal and our non-tidal, or our creeks sampling and our tidal estuary sampling. Our volunteers, the sassafras samplers, are the ones who work through the tidal sample or the non-tidal sampling. We have 16 sites that they test year-round. We just started doing year-round testing in 2010 for the first time, and we've continued to do that this year. They collect pH, dissolved oxygen, temperature, nitrate, ammonium phosphate, and turbidity. Our monitoring program was actually modeled after the Chester Rivers program. We're a sister organization of theirs. We're very close by geographically, and we've used a lot of the same protocols that they used. For the tidal sampling, this is run by the riverkeeper, some volunteers occasionally, and our interns. This is run from April to October. We have 7 sites up and down the river, and we collect the total phosphorus, total nitrogen, chlorophyll A, top and bottom turbidity, pH, dissolved oxygen, temperature, salinity, and those last 3 we do every half meter, just as the or meter, depending on the depth of the site, just as the MTAC protocol describes. And for this presentation, our other projects, I'm calling them the special teams. I guess the football season's been in the back of my mind recently, so we have a lot of side monitoring projects where we incorporate volunteers throughout the year too. Our Stream Waders project, we do that every 3 years. 2012 is one of the years we're going to send volunteers out to collect benthic samples and get some data on the benthic macroinvertebrates. We have some invasive species problems on the river too, which I'm going to talk about a little bit later. We did experiment with a little bacteria monitoring last summer. We worked in conjunction with the Chester River Association. We're looking to possibly continue that this year and maybe even start using that bacteria data for a report card. Lastly, our phytoplankton monitoring network. Algae blooms are a very large concern on the Sassafras River, and I'll have another slide on that a little later. So here's a snapshot of all of our sites. Our blue sites, those are our riverkeeper sites, the once-a-week tidal sampling sites. The green there are the non-tidal sassafras sampler sites, and we also have 3 DNR stations. Some of them continuous, some of them once a month, and they supply a lot of different data. The one furthest upstream here does have a chlorophyll sensor, and that's one of the areas in the river where we experience some of the highest concentrations of algae blooms, actually toxic algae blooms. We get microcystis blooms up there, so we're very fortunate to have that to track what's happening. So getting into the actual grades, this is 2000 data. Our creeks are non-tidal areas. We have some work to do here. Our phosphate and our creek bed organisms are very, very low. We got a 0% with our benthic sampling. Very low quality samples there. As I was talking about the woodland gullies, that's no surprise that we have really high problems with the phosphate readings here. We have a lot of erosion going on. We have a lot of farm land that where in some cases there's erosion problems, and these woodland gullies are really just contributing to the sedimentation in the river. This is a view of the entire watershed and all of our non-tidal sites. Each of these little pie slices represents 1 month throughout the year, and just on a pass-fail basis, you can see which sites are okay and which sites are not, just based on the phosphate readings. And phosphorus is really our biggest concern at these non-tidal sites. Typically, as you get further upstream, you get more into these first-order streams, we tend to get higher readings of phosphate. As you can see, there's a lot of red on this screen. And in the green areas where we have green, those happen to be just below dams. So there's a lot of sediment getting trapped there, and I think that's the main reason why we don't see as much red at those sites. our upper estuary, and I'm going to back up for just a second. I forgot to explain one important thing. You see these two different colors in the river. We have a light blue and a dark blue. We're a really small watershed, but we chose to divide these up to kind of highlight the differences that we see between the upper river and the lower river. If we just kind of homogenize this all into one grade, it wouldn't really give an accurate picture of what we're seeing, and that's the reason we chose to do that. So when we get to these next slides, that's what we're talking about. That blue area is our upper estuary. So we see a little bit better scores here than we did at our creeks, but we still have very poor light penetration, poor chlorophyll A, very poor phosphorus. Remember here we started testing total nitrogen and total phosphorus, not quite the same as our non-tidal sites. Oxygen, very, very good. We can attribute that to the algae blooms which persist a good part of the year when we're out there testing. These pictures down below, this is microcystis on the left, and on the right it may look at first like some SAV beds, some really healthy looking SAV beds, but that's actually algae that's just being kind of pulled into some current into the river, and it's just making these interesting looking streaks. So overall we see a little bit better scores than we did at our creeks, but still pretty poor. In our lower estuary, our scores jump up dramatically, but we still have some concerns with the water clarity. Most of the other indicators did improve. One thing that's not captured here is bacteria. We didn't do bacteria testing at these sites in 2010, and there's a beach nearby our final sampling site, right where the bay meets the mouth of the Sassafras River, Betterton Beach. For many years, long before I came on at Sassafras River Association, they've had bacteria problems where they have to actually put up signs, advisories telling people that it's unsafe to swim there. That, I think in 2010, that was, the signs were up from July until September. So there wasn't even a break. There wasn't a lot of rain throughout that period, and they just kind of seemed to keep high bacteria concentrations. A couple of reasons why that's the case. We think there's a wastewater treatment outfall right there at the beach. There's also a stormwater pipe outfall right there at the beach, and there's seagulls that just love to hang out on that beach area throughout the year. So people like to blame it on the seagulls, but there's lots of choices there, obviously. So that is a concern. We do have advisories in other places in the river too, but it's not a major problem as it is maybe in some places on the western shore. So these are bacteria bandits down here. Just to give you a little bit more specific idea of what we're looking at as far as the concentrations from the headwaters to the mouth of the river, and and there's a lot of information on this graph, but these sites, WK2 to WK9, those represent our 7 riverkeeper sites from the headwaters to the mouth. So obviously, we got the Empire State Building over here, and we have a little flat over here. So there's quite a difference between the headwaters of the river and the mouth of the river as far as chlorophyll concentrations. And we did the same graph with the phosphorus and the nitrogen, and we saw really the same thing. So the trend, the take-home message that we always tell people, and we've seen this both in 2010 and 2011 now that we've collected this data for 2 years, is that we generally see water quality scores improve as you get closer to the bay. Not what a lot of people would assume. A lot of people like to blame the Susquehanna River for our water quality problems, but in this case, the pollution is getting diluted. So putting this all together, obviously we're summarizing a very complex ecological system here, but I think we're doing a fair job of it. We've highlighted some trends, and we've seen some areas where we definitely need improvement. And as a watershed organization, we're using this data to help prioritize our restoration work, and it's really helping us move forward to understand how the ecology of our watershed really functions. It's also going to be kind of our benchmark for success in the future, for measuring our success. Obviously, there are concerns that are not captured in this score. We already talked about bacteria. The algae blooms is a huge one, too. Throughout the summer, folks from DNR are coming up to make sure there's not too much microcystis in the water, that it's not unsafe for people to go out and get into the water and swim in the water. There have been years in the past where they've had to put up advisories or shut down public boat launches because of the microcystis levels. Fortunately, for the last 2 years, it seems like there's just enough flow. Not that there's a lot of flow, but there's just enough flow coming from our upper estuary to kind of flush out these algae blooms every once in a while, so they're not so stagnant and continue to bloom. But we've seen some really amazing trends in the last 2 years. We see extremely high pHs, extremely high oxygen contents. It kind of follows the diurnal cycle of the algae as they live and switch from photosynthesis to respiration. But we've seen pHs above 10 actually, extremely high. And if you may or may not know, as the pH rises in an environment like this, the phosphorus, the sediments that are in the bottom of the water column, they actually, the pH affects it in a way that the phosphorus is unbound from those sediments, and it's actually a self-sustaining bloom, so that these algae can utilize that phosphorus that's bound up in the sediments. There have been a few PhD students that have been doing studies with that in the last few summers as well in the Sassafras River. So, based on all of that, we decided to participate in this really amazing project called the Phytoplankton Monitoring Network. It's a project that's led by NOAA. NOAA trains volunteers. It's pretty intensive training as well too. It's not easy to identify these little critters under a microscope unless you have a lot of experience doing it. But believe it or not, we have 5 volunteers that are doing this bi-weekly, and we're starting to develop a long-term data set. That's really the goal, is to start collecting this data on a more routine basis, which is not being done now. There's really no funds or staff ability to do that from NOAA or from DNR. And it's also a way for us to help track blooms. We can't be on the water all the time, but if we're out there at least grabbing a sample bi-weekly, then we do have a little better idea of what's out there. We did find plenty of microcystis this summer, Anabina as well, usually right next to the microcystis. Lepidolindris is another really common species, and once you start learning these, it is actually really fun. A lot of them I never could figure out, but it was a lot of fun anyways. Another thing we're not capturing are alien plants. I know that's something that this group has talked about a little bit, not just plants, but alien animals as well, invasive species. Water chestnut is a very big problem in our river. There's only a few places in Maryland where you currently can find this, but it's been introduced quite a while back. Actually back in the 60s, I believe, was when it first appeared in the Sassafras River. They kind of bombed it with some herbicide and it went away for a while, but then just in the last 5 or 6 years it's come back. And so each June and July we have volunteers that go out and pull this stuff, and we just kind of keep tabs on it to see how it's coming back. Purple loosestrife, found an occurrence of that last summer. If you're familiar with that plant, it can get out of control really quick, dominate the plant community on the shoreline. Although it's very beautiful, it's not very good for diversity, and it can displace native plants. Zebra mussel, the first occurrence of the zebra mussel south of the Susquehanna River was found this summer in the Sassafras. So that's a very big concern. Part of the reason it might have migrated to the Sassafras River is because of the really low salinities we experienced this year because of all the rain, the hurricanes. We had really low salinities for almost the entire summer. High spring rains, and then the hurricanes just kind of just saturated with precipitation this year. So that's an ongoing concern. We're trying to alert the public about that, to report it and monitor that. Lastly, Brazilian eldia, or what people call it just waterweed. Just this past summer, this stuff has exploded in our river. I had people call me on creeks that had lived in the same house for 15 years and had never seen any SAV growing in that creek. And they called me and said, it's wonderful. We have this beautiful grass growing in our creek. Please come look at it and identify it for us. And lo and behold, it's this horrible invasive. You may or may not know, but this one's so bad that it doesn't even need to reproduce like other plants. Just all you need is a little fragment of the plant to break off, and that's all it needs. It'll resprout and grow from that way. I think it was introduced from aquariums actually originally. So that's a big concern, and that could also be part of the driver for those high pHs and really saturated oxygen waters that we had this summer. That could be part of the reason we had such high pHs, really unprecedented high pHs this summer. The combination of the invasive aquatic vegetation and the algae blooms just kind of pushed it over the top. So, at first glance, a lot of our scores, they may look pretty good compared to other rivers, but again, there's a lot of things that we're not capturing. We've got a lot of work to really find a messaging tool for that, I think, to let people know that here's our grades based on these parameters, but we do have a lot of other concerns, a lot of things that our watershed organization is working on to address these other problems in the river. To recap everything that we saw, typically water quality seemed to increase as we moved downstream, as we moved closer to the bay. DO and pH levels were basically within their critical thresholds, but again, we had pretty high pHs. There is some language in COMOR that says you can go between, I think, 6.5 and 8.5. It's allowed to go above 8.5, in summer periods, but generally we want to keep between those thresholds. So we had above 8.5, but largely we were okay. High TNTP throughout the year. Chlorophyll concentrations peaked in August, and there seemed to be kind of a horseshoe effect in that graph. We had a little bit of a down period in the middle of the summer, but it was high in the beginning and the end. So overall, water quality worsened upstream again. So precipitation is always a huge driver in what water quality data is each year. And so again, we can attribute the wet June, the dry July and August, and then there were some fall rains as well that kind of led to the second round. So that's all I have. How did I do on time?